In this video, we're going to put together a simple parametric assembly. We're just going to do that in part design. I'm not going to do it in assembly 4 or any of that. I'll just show you how we do it in part design. But more, I want to concentrate on how you would go about building parameters to make sure that the thing always assembled. So let's take a look at it. The version of FreeCAD that I'm using is 0.19. 0.3 is what I downloaded. I'm not 100% sure if that is really the 0.3, but I'm getting ready to move over to 0.2. I've tested it out a few times. I think it's very good. So I'll probably use that in the next video, but for now, we're going to go with 0.19. And we're just going to use the part design workbench. First thing we're going to do is create a new file. So we're going to go into the macro. Recent macro startup. Remember, if you don't have the startup macro, you can look at one of my other videos. You'll find the startup macro in there. Basically allows you to set up your own files. And so what we're going to do is we're going to call this a simple parametric assembly. Save that. And I'm going to do it in the XZ plane. I'm just going to create a revolve here. So I'm just going to take this polyline tool and I'm going to create a revolve. Do something like this. To there. To there. Remember, with our revolve, we have to join the back part of it. So I'm going to close that for now. Bring that to the middle. And I'm just going to revolve that. And that's the part that we wanted to make. Now, one thing we need to do is to keep this organized. So I'm going to rename this body to pin. I'm going to call that a pin. Now we have our pin. We're going to go back to our part, make sure that, double click on it just to make sure that's the active part. And I'm going to add, actually, you know what I'm going to do? I'm going to add another part. So I'm going to go up here, I'm going to add a part. And inside that part, I'm going to add a body. And I'm going to rename that body to block. So we're going to have a block that this pin fits into. So I'm going to do a quick sketch for that. I want to sketch it on this plane. Okay. I'm just going to do a square block or a rectangular block. I'm not constraining any of this right now because I'm going to come back and put my dimensions in and do all my constraints and everything to make sure it all fits together. I'm going to pop a hole in my block and we'll close that. And then we'll just pad that. And now I have a hole in the block and my pin is going all the way through, so clearly my hole should be this diameter, not this diameter. We'll fix that in a minute. Okay, and then finally what we want to do is we want to insert something that goes through here. So I'm going to create another part. Go up here, create a new part, create a body. We'll rename that body. And we'll call this retention. And you can call them whatever you want. You don't have to call it the same as I'm calling it. You don't have to do it the same way that I'm doing it in terms of, you know, what fits into where. This is really to show you the concept of how to put something together like this. Clearly, if you have a different assembly, you're going to do it differently, but if you follow this sort of model, you should be able to do almost anything. So I'm just going to do a quick sketch here. It's going to be on this plane. That's my XZ plane. I'm going to use my sectional view again. And what I want to do is I just want to create something that is attached to there, about that diameter. Close that. And then I'm going to pad that. And I'm going to pad it symmetrically. And I'm just going to pad it out far enough to go through both pieces. And then what I'm going to do is I've got to create a hole through this guy as well that's going to suit that pin, and a hole through this that suits that pin. But for now, you get the idea. So what we're going to do is we're going to assemble that pin into this block, and we're going to assemble it with a retention pin. So when we do that, we want it all to fit properly, and right now, of course, it doesn't. So we're going to do that next. And again, for clarity, what we're going to do is we're going to rename the parts as well. We'll just call them the same names. So we're going to rename that to pin, Mr. B. And we're going to rename this to block. And we'll rename this to retention. Notice how FreeCAD's taking care of putting the 001s on the end there because it knows there's something else with the same name. So it's keeping us all organized. Now, next thing we want to do is to create a spreadsheet, and we're going to start putting some dimensions on it. So go to the Spreadsheet Workbench, and then we just click New Spreadsheet. And then we're going to open our spreadsheet by double-clicking it. And then we're going to go up here to the Windows and say Tile. So now I can see my spreadsheet and my model side by side. So it's just Windows and Tile. So what we want to do is to keep all of our dimensions organized. And the important thing is going to be, we're going to lead with the name of the part. So for the pin, remember the pin is this part. This is the retention. So if we make pin, which equally could have been called shaft, but I called it pin, so we're good. So I'm going to say pin, small diameter, pin, large diameter, pin, large height, should say large diameter height, I think, so we keep it clear. Pin, small diameter height, and I'm going to leave a couple of spaces if I want to add something. I'm going to say block height, and I want to say block width. I'll say block length. Leave a couple of spaces. Retention, diameter, retention, length. Now, I'm just going to take my spreadsheet, and I'm going to use this macro, the easy alias macro. I know some of you had some problems to find that, and if you do have problems finding it, you can reach out and I will make sure you can get a hold of it. It is still available, but you have to be able to find it. I'll put a link below to where I found it, and then you should be fine. But it does work, still works, it works perfectly well. So the thing we need to look at next is what things do we want to calculate and what things do we want to manually set. So the retention pin diameter, we're probably going to manually set that at 3 millimeters. The retention length is probably going to be the same as the block width because I want it to be flush, right? So let's do that. So we'll say this equals block width. It might yell because it doesn't have anything set, but the block width is going to be, let's say 10. And now, do I want that flange to be aligned with that? The large diameter aligned with the block width as well. So maybe I'll make that equal to the block width too. So what I'm doing is, whatever my block width is, then this large diameter on the pin will be the same. Because clearly that hole that we have in the block, which we haven't put a parameter in there yet, but that hole is going to be the same as the small diameter there. So the small diameter we can call 6 millimeters. Hole diameter, we'll make that equal to the pin small diameter. But now what will happen if that pin and that hole are the same size? They're not going to go together. So we need another dimension here, which is going to be our clearance. We can make our clearance 0.3 or something for now. So then this block hole diameter is going to be the pin's small diameter. It's got to be bigger than that, so it's going to be plus clearance. I haven't already set up my clearance using my easy alias, so it doesn't know that there's an alias called clearance. There we go. So now the block hole diameter is correct. So it's this 6 plus my clearance, wherever my clearance is. So this diameter here is going to be this diameter plus my clearance. And I can use, multiple clearances if I want, but for the sake of simplicity, I'm going to just stick with one clearance. So then my retention pin is 3. When I create the hole in those two, I'm going to make those holes the retention diameter plus clearance. So I can do that actually as I set those dimensions. So let's go back into our sketches and let's start setting up some of our dimensions. Oh, we do need a height for our small diameter is going to be our block height as well. So maybe we'll make that block height, if we're only making it 10 wide, maybe 5 high. And then this small diameter height, because we want it to be flush from that edge to there. So we're going to say that will equal the block height. And so now I have the block height is going to be the same as that. So let's go into our sketches and start setting up some of these diameters or some of these dimensions. So I'm just looking, the pin large diameter we said is going to be the same as that width. Pin large, so this should have been the block width. Let's get this right. That's the block width. The diameter height can actually be anything we want it to be, so I'm going to just make it 3. And now what I like to do is if they're referenced from somewhere, I like to say that's calculated. It just lets me know not to change it. So this is calculated. Even there's no calculation, it's more referenced. But I just put calculated alongside just so I know not to change it. And I'm going to change that one to 50. This one is calculated. And I just noticed I haven't easy alias that one. So take care of that. this retention diameter, retention length. So this one is calculated as well. So that tells me not to change those. Now let's go into our pin, go back into our revolution, back into our sketch, and I'm actually going to go and turn off the other parts so we can see what we're doing. I'm going to use my sectional view. We'll go in here, and now we have all of the information we need is over here, so we can set our constraints. Now remember, there's some auto constraints that went on, so we have the vertical and horizontal lines are all on there, and coincident points where it's touching those lines. So now this dimension needs to be the pin small diameter time divided by 2. So let's go ahead and we'll do that. We'll say OK. And that's, so you can see it, that's our first one all set up. And then we're going to go with a height. So this one's going to be pin small diameter height. Remember that pin small diameter height is coming from the block height. So if I go there and click on it, you'll see it says block height. So whatever we make our block is what that's going to be. Then we want a dimension. We're going to go back over here. We're going to dimension this guy. This one is our pin large diameter height. So spreadsheet. Just straight up. Okay. Up there. Just going to name this one. It's from the spreadsheet. So it's pin large diameter. Divided by 2. Because that's only dimension or radius because we're on a revolve. And so that will now fully constrain. If you look, we're fully constrained, and that's the size of our pin. So what I'm going to do is I am going to turn on my other parts. And now you can see my pin is completely different size. What we'll do is we'll go into this retention next, because it's a simple piece. We'll go into our sectional view, and we will dimension that. We want to call that our retention diameter. And then one thing we need to do is we need a dimension that goes from here to the center of that. And for now, I'm going to just leave it at 5.43. That's fine. Close it. That just locks that in position. In a minute, we're going to work out where we actually want that to be. And we'll do that in our spreadsheet. Okay, one more to do. We're going to go in our block where the pad is, and we are going to dimension that guy. We go to our drawing. We're going to give that a dimension. And we set the block hole diameter, which we calculated. So go in here and say block hole diameter. So now you can see my block hole diameter is 6.3. And then we're going to dimension the side here. This is going to be my block width. And then I want to do my geometry here. I should have actually done that first. I'm just going to center that around that point there. That. And then we want to do this dimension here. And that's going to be block length. And notice as you type it in, it offers you options around what you've put in there. Okay, so we can close that. And now our block is resembling what we want it to be. Now the height of this block height, is going to be whatever that pad was set to. So this pad went to 10, and we now want that to be block height. So we just set that one up. And now we can see there may be an issue, which is the origin of my block is the same as my origin of this pin, and the distance that this guy goes up to. So we need to do an offset for this, and that offset is going to be whatever that pin large diameter height is. So let's go ahead and we'll do that. So we just go into the sketch, we go into the attachment, the position, the z-axis, and we call that spreadsheet pin large diameter height. Pin large diameter height. Say OK. I'll just tab away from there. And now you can see that my block, this and this are at the same height. I have my clearance around here, and I have my outer flange, or the large diameter, is in line with this surface, but it's also the same diameter as this width. And all of that is parametric right now. So the next thing we want to do is we want to figure out where should the center of this hole be from the bottom of here. So it should be the block height divided by 2 plus the pin large diameter height. So we're going to do that next. We'll actually insert a row, and we'll say retention center, and we're going to call that, actually I'm going to, now remember when you do your easy alias, you need to select the spreadsheet as well. Otherwise, easy alias doesn't work. So we'll go on here, easy alias, and then we're going to make this equal to block height divided by 2 plus pin large diameter height. And so now that will give us the center of where we want that pin to be. So all we've got to do is go back in that sketch, go to that dimension, and we'll change this to Spreadsheet and retention center. Right there. And we'll close that. And now our pin is exactly where we want it to be, but we don't have any holes that the pin goes through. So now we need to go to our block. Let's make the block the active body, and we're going to create a new sketch. I'm going to do the sketch in this plane. We'll say OK. Sectional view. I'm going to put a hole in here. Basically where our hole is going to go. And we're going to give that a dimension from there to there. And that's going to be the same as the retention center. So Spreadsheet, retention center. So now that's the same center. And then all we need to do is dimension the diameter for it. And the diameter is my retention diameter plus my clearance. And I'll close that. And now I want to make that a pocket. I want it to be symmetric about the plane through all. Because it doesn't matter, because it's only all of that block that is in that part. It's not going to go through these parts. Okay, one other thing we haven't done is our retention pin, where we padded that pin. This length should be equal to our block width. And you see how naming these parts properly is the way you can make all of this work. If you don't do that, you're going to run into trouble very quickly. So there's a hole in the block with clearance for the pin. And then we're going to put a hole in the pin. The hole in the block has a clearance for the retention pin, but the pin here, which you probably should have called shaft to make it less confusing, but that pin, we're now going to put a hole in that. So what I'm going to do is turn off that block for a minute. See, I'm going to put a hole through there. So I'm going to make the pin my active body. And you can tell it's the active body because it's highlighted. I'm going to do a sketch. And I'm going to make sure I get that sketch on the right plane. So it's this plane we want. Just say OK. And we're going to draw, it's just the same thing that we just did. I'm going to just select that first. We're going to draw a hole. And we're going to dimension there. And we know that dimension is retention center. So Spreadsheet, retention center. And then we're going to do that diameter. And that diameter is going to be exactly the same as the one we did before. So it's going to be retention diameter plus clearance. Close. We're going to do the same thing with this. We're going to do a symmetrical rule. Say OK. You zoom in there. Now have a hole through that. We have a hole through our block. If I turn the block back on, and everything goes together. Now let's try changing some spreadsheet info. So for instance, we want to change, scrolled up accidentally, we want to change the pin small diameter. That should change our block hole, but it won't change our retention pin. So we've got to be a little careful there, because our retention pin right now is an arbitrary number. So if I make this too small, then that pin might be bigger than that and it'll break our model. So what we should do is say that that pin is half the diameter of our small pin. So let's do that. Let's go here. We're going to say equals pin small diameter divided by 2. Now that came out the same number, but now if I'm that is calculated. And let's just make sure everything works. So let's go. Let's just move this over this side and move that one over that side. Because my little box is coming up over the spreadsheet, I don't want that to happen. I want you to be able to see what we're changing. Okay, so if we change our small diameter to 4, our pin changed, our hole changed, the hole that fits in changed, everything looks good. Now if we change our block height to 6, everything changed, the block height changed, the center to that pin changed, it stayed on that corner. So everything looks good there. And then if we change this large diameter height to 5, everything moved up again, so it's all staying in position. The assembly is where we expect it to be. And I don't like it. 5, so I'm going to change it back to 3. You can see it all moves up and down. And then if we change our block width and we go to 15 for that, what happened now is the pin got longer, the retention pin got longer, this diameter got bigger because it's all parametric. And then, of course, I can change our clearance. If we say, let's just make it 0.2 clearance, now everything's a little tighter. What I would normally do, I think, is I would have a different clearance for this hole than I did for this hole. And I might make the clearance a percentage of this hole. So I might say, you know, if I want the clearance in there, I can do a percentage, calculate that as a percentage. So that would work perfectly fine. What else have we got here? So, that should be marked as calculated. Just to keep everything honest. We got everything that's calculated, everything that we can change. I can change the length. It's arbitrary, so it doesn't really matter. I can change that to 30. Just changes my length there. Remember, that's everything is symmetrical around a center point, so it changes from both sides. I can change the block height, the block length, the block width, can change the size of the pin. I can change lots of things. I can break the model if so my block height is set up now. If I make this massive, it'll make that pin bigger and it'll break out the block height. But to be fair, you might have to, or you might want to keep some sensible norms in there. I don't think that's a major issue. I could calculate the block height based on this pin diameter. Because if the block height changes, my small pin height changes. Pin small height is the same as the block height. So yeah, so that would change. So I could do that. What we could do is we could say, if this block height has to be at least 3 times that retention pin diameter, and the retention pin diameter is all driven from there. So let's do that. Let's see how it works out. So that's going to equal retention pin diameter times 3. And then block height is now calculated as well. So now if I change this to be 5, it'll change my block height based on the size of that pin. And that'll prevent it from breaking when we make changes. There may not be a practical calculation that you want, but again, it's just to show that you can do that. You can change how the parameters work together to make that always fit together. No matter what you do with that shaft, that pin, you have a clearance. And this is how you can make a simple assembly. As the assembly becomes more complicated, more complex, you're probably going to find that you run into issues, particularly circular issues, where you're calculating too much, and so it can't solve the calculations because one is changing the other. So you just have to be a little bit careful with that. But for the most part, as long as you keep things organized, you name things logically, and you go through the spreadsheet in a logical manner, and you mark what you've calculated so that you're not manually changing something that you wanted to calculate, I think you can get a fairly complex assembly to work quite well with FreeCAD's parametric technology. So hopefully you enjoyed that. Just a little bit of fun with parametrics. I do enjoy making parametric models, and hopefully you can see the value in doing that with your own assemblies. Obviously you can make more pieces, more parts. You could do it in an assembly as well, but I just did it in part design because honestly that's just as easy to put something like this together static. I think if you do something that's more interesting, more complex, please let me know. You can shoot me a line, and I'd love to see the models that you guys come up with. So if you enjoyed the video, please give it a thumbs up. Of course, if you're not subscribed, I would appreciate it if you would subscribe. I'll show you now that 70+% of the people who watch the videos are not subscribed. So if you would just press the subscribe button, it doesn't cost you anything, it's free, and you can be subscribed, then you'll get notifications every time I put a new video up. If you do want to contribute to the channel, you can always join our Patreon, or you can become a member of the channel here on YouTube. You'll both get exclusive videos that I create that are quick, simple videos with lots of tips and techniques and new features that are coming out in FreeCAD, and anything that I find that's interesting or exciting, I'll create a video and provide that to my patrons and my channel members. So again, thanks for watching the video, and of course, if you don't mind, go over to my other channel and subscribe there. I'd really appreciate it. Thanks. I'll see you in the next one.